Hi everyone, in this tutorial I want to show you how I made the effect of tearing chocolate. At the beginning of the lesson, I want to warn that I can make mistakes in some points. In any case, I will always try to help understand what I could not convey in the video. The final scene will be available on my Gumroad with all settings. Enjoy watching. First, I want you to know that these two locators are the end position of the animation. I also have another locator in which I placed the node settings to change them in one place. Now I will hide the locator with the settings so that it does not interfere with us. The first thing you need to do is model the basic shape of the chocolate, which you must place at the origin of the world coordinates. After that, I created a new mesh and added a merge mesh node, to which I connected the base mesh of chocolate. In the second step, I used the merge mesh node again, to which I connected the mesh from the first step. Next, I used the assign selection set node to create a selection, which will separate the chocolate mesh into two parts. I use selection operator polygon and conditional modifier to select polygons that are above 0 on the x-axis. Then, using the jitter node, I distorted the position of the central edges along the x-axis. I connected to jitter the previously saved selection along the x-axis. Then, using boundary edges, I converted the selection into the boundary edges of these polygons. Then I added an edge split node, connecting the previous selections to it. So I divided the mesh into two parts. And at the end I added an assign selection set node. This selection will be the name of the material in what follows. In the third step, I isolated the two parts of the mesh from each other to different objects. Using the merge meshes node, I connected the mesh from the second step. Then, using the delete node, I deleted the polygons of the right side of the chocolate. And for the right side I deleted the left side of the polygons. In this way, I separated the parts of the mesh from each other. The next three nodes, I connected to both parts, so as not to duplicate them. With the thicken node, I added thickness to the top layer of chocolate. Using the edge bevel node, I made a bevel on the edges of the mesh thickening. Using the by angle selection operator, I selected edges with an angle greater than 40 degrees. And at the end I added a set polygon type node to smooth the mesh. The transform deformer is global. I connect it to each mesh of a specific side that will move. To get rid of duplication, I connect it to several objects to create motion animation. So I move both parts apart. Now I will show you how I animated the positions of the locators. These are the locators that are connected to the transform deformer. When you add a transform deformer, its locators are always at 0 coordinates. The first thing I did was set the parameter from 0 to 100%, and animated it. Then I created two locators, one green and one red, and moved them. Then I added a matrix blend node and connected to it the world position of the green locator. Input A is not connected because the initial position of the locators are in 0 coordinates. You can adjust the position and rotation of the locator to get the end position of the animation. I did the same for the rotation. Matrix blend allows us to gradually switch from one position to another. I connected the animation channel to the blend channel so we can animate the locator positions. Then I connected the output channel of the matrix blend node to the transform deformer locator. In this way, I animated the position from 0 coordinates to the positions of the colored locators. What I used the following three nodes for, I'll explain a little later. Let's get back to our mesh operations. In the fourth step I made the inner mesh, which will be the filling in chocolate. First action, I added a cube from which I made a plane. I set the number of segments not too much. The main thing is that they are about the same size. I got the size values for the X and Y axes from our base mesh. I added a mesh info node and connected the base mesh to it. I connected the size of the base mesh along the Y and Z axes to the parameters of the cube node. On the Z axis, the size will be 0. Then I added a thicken node to make the polygons extrude along the Z axis. I got the offset value from the mesh info node. The channel of the minimum value on the x-axis I used for the left side. Here is the size. This part will be the size of the maximum value on the x-axis. I divided this value by 4 so that the inner part is not too long. I then saved the front and back polygon selections to use in the next step. I named these selections front and back. I then added a surface constraint node to make the shape match our base mesh. I connected the base mesh to the surface constraint node, so the polygons take the desired shape. You can see how the mesh sticks to the base mesh of our shape. I did the same for the right side. The right side is slightly larger because the base model is more offset on the x-axis. So this part is a bit bigger. I also connected a transform deformer node so that these parts move with the rest of the objects. In the fifth part, I connected the front polygons and converted the result to curves. I connected the two previous objects using the merge meshes node. Then using the bridge node I connected the front polygons of the two parts. This is the selection of the front polygons that I created in the previous steps. These front polygons are connected to each other. Then I saved the selection of polygons created by the bridge node. Then with a new subdivide I increased the number of polygons. For polygon stretching effect I used magnet deformer. In its settings, I specified the selection created earlier. To place the deformer and falloff in the middle and specify the value of their range action, I used a node that calculates the distance between two objects. These are the locators of the deformer's transform nodes. I connected two locators to the matrix blend node to find the middle position between them. In the matrix blend node I set 50%. This will be the middle position between the locators. After I used the direction constraint node, with which I calculated the rotation angle. Now the direction of the magnet deformer and falloff will be rotated to the locators. I then used the measure distance node to calculate the distance which would be the range. The farther two locators are from each other, the greater the range length. Now it's related to animation. I will hide the deformers so that they do not interfere with us. The next step is to delete the back polygons. For this I used the delete node. Here are the polygons I removed. Next, I made two selections of edges. Using these selection nodes I selected the edges in the direction of the length of the mesh. These are the edges that I selected using selection nodes. Next, I made another selection using the first two selection nodes. This is the selection that I will subtract from the previous selection in the next node. Next, using the edge to curve node, I converted the edges to curves. I connected the selections that I created in the previous step to select the edges I need. Next, I cloned the curves to get more curves and squeezed them inward a bit. And with the last step, I added the set polygon type node. Nothing is happening at the moment, but if we disable the edge to curve node and clone, we will see a smooth mesh. Turn back edge to curve and clone. In the sixth step, I split the curves into two objects. Using the merge mesh node I connected the curves created in the previous step. Then with the delete node I removed some of the curves, making them less frequent. I use select by range to remove the curves after a certain step. I did the same for the right side. The curves are in the same place but their animation growth will be different. Also you can use other selections to get different curve removal. Next, I created a profile and extruded it along a curve. I created a new object and connected the curve sweep node to it, to which I connected the curves. To create a profile, I used the n-sided node, which I also connected to the curve sweep node. So I made something like fibers that will diverge from each other. I did the same for the other side. Now I will show you the settings that I used in the curve sweep node. The difference between the sides is only in the direction of the scale gradient curve. To animate the size, I used the animation parameter, from 0 to 100 cents. That is, from 0 to 100%, my profile size decreases to a certain size. In the 9th step I connect the parts created in the 4th step and add some noise. Using the polygon bevel node, I extrude the front polygons a little further away. I am again using the previously created front polygon selection. Next, with the jitter node, I distort the front polygons. And finally, using the merge meshes node, I connect the extruded curves in the 8th step. Now these parts are one object. In the 10th step, using the voxel node, I merged the mesh of objects into one mesh. By activating this option you will get the generated voxel from connected objects. This parameter affects the density of connection of an object with each other. Thus the mesh of objects merges with each other. In the 11th step, using the merge meshes node, I converted the voxel to a mesh. In order to narrow the mesh a little, I used the push node. I then smoothed the mesh using the smooth node. Let's see how it looks in motion. Next, I used 3 surface constraint nodes with which I attached the mesh to another object. I connected a grid with nuts to the first node. To make the nuts I used a sphere and a jitter node to distort a little mesh. Thus, the nut will not be a perfect even sphere. And at the end, I added an assign selection set node, in which I entered the name of the material. Then I created 2 instance duplicates. Since the nuts are inside the locators that are hidden, you need to turn on their visibility. Nuts must be inside the locators so they move with the rest of the objects. This is how I made the nuts. Then I connected them to the surface constraint node so that they attract the filling mesh. I connected the inner mesh to the next node. To the 3rd node, I connected a mesh of external chocolate. Now mesh follows the shape of chocolate. With the next node, I smoothed the mesh. And at the end I created a selection which will be the name of the material. This is how I created the effect of tearing 2 pieces of chocolate. Now I will include a mesh of the top layer of chocolate. Let's take a look at how it all looks together. I think it looks good. In any case we can adjust the parameters by changing the appearance. We can change the end position of the 2 parts by moving and rotating the locators. If we go to frame 0, our chocolate will be broken into 2 parts. Let's fix this. To do this, we need to hide the mesh of the 2 parts and turn on the visibility of the base mesh. Let's add a visibility channel to the schematic view. Using the condition node, we can influence the parameter, taking into account the input values. When we have the animation parameter set to 0, the base mesh will be visible. When the value is greater than 0, it will be hidden. I set the value to 3 because that corresponds to the index number of the hiding option. Let's connect the animation parameter to the condition node. In order not to move the locator, I will add an add node and connect the animation parameter to it. And connect it to the visibility channel of the base mesh. For 2 pieces of chocolate, I will do the same. But when the animation value is 0 it will be hidden. I'll add a condition node again. Now the mesh of 2 chocolate pieces is hidden when the animation value is 0. I did the same with the rest of the objects that should be hidden at the beginning of the animation. Now we need to add the thickness of the base mesh when the animation parameter is 0. To do this, I added a thicken node to the base mesh, which will be activated only when the animation parameter is 0. I will connect in a value that corresponds to the thickness of the top layer of chocolate. Let's look at the result. By changing the final parameters of the curve sweep node, we can influence the final shape. This way we will leave some fibers at the end of the animation. Let's see how it looks on the render. This is the result I got at the end. Thanks for watching. I hope I was able to convey the basic information on how to make this effect.